Okay, morning everybody. The title of my talk is Tracing Your Data's DNA. So first I should introduce myself. So my name's James Bowkett. I've been a Java programmer for about 25 years actually, which I'm going to stop saying that soon because it's getting too embarrassing to be that long in the tooth. But I've had a career in and around finance. Mostly around kind of data-centric applications. So I usually say that I've made a career from kind of shoveling data from one side of a server room to another, but that's now kind of all through kind of data streaming, big data, and gone through all the trendy approaches with data over the years. I'm from a company called OpenCredo. We have kind of three major specialisms, but we also try to weave kind of the human element through that. So most notably, some work we've been doing around kind of data mesh. And the data and data mesh solutions is probably what's most appropriate for this talk. So as I said, the title of the talk is Tracing Your Data's DNA. Now, that might seem a little bit abstract, but what are the problems that we've got with data today? So data is big. So there's this often quoted statistic that we're generating 2.5 quintillion bytes of data a day. It was funny actually, I was trying to find the source of that. Forbes reference IBM as the source and IBM reference Forbes as the source, so there's already a circular dependency there. But to give you an idea of how big 2.5 quintillion bytes is, 10 quintillion is the estimate for the number of insects that are on planet Earth at one time. I realize it's probably a little bit early for a simile like that, but that gives you an idea of how many bytes of data we're actually generating every day. Now, we've also got sort of loads of different ways of kind of processing data, of working with data. We've got data streaming, we've got batch data, we've got systems of record. And now all of this this data problem isn't getting any easier, right? And if you think about the architectures and techniques that we're applying to data today, data is, it sounds like a bit of an oxymoron, data is disparate and distributed. You take something like S3 or you take some kind of clustering database, something like Cassandra or Big Table. It's disparate, it's distributed, but it's also connected. We are using data to derive other data and to derive other facts that we know about either data or a thing or a behavior. And on the back of that, explaining the decisions we make using data is going to become law. There's part of GDPR, in fact, which says that you have to kind of be able to justify why you did a certain action. What is the data that you hold on somebody? So actually, if you have some kind of machine learning model, you have to make sure, or you have to be able to explain, whether it's sexist or racist or any other ist, and why it came to that decision rather than being inherently in the code. And as I mentioned, kind of data mesh, data is derived from other data sources as well. As you have these data sources and you combine them together into some whizzy new report or some whizzy new service, you're actually deriving yet more facts and building on your foundation of data. So what's data lineage then? So I put a bit of a definition up there. I think I nicked that off Wikipedia, which is the single version of truth for everybody. But really, in short, given any piece of data, whether that's a document or a row, I want to know where that data came from. What are the parents of that data? Where does it get its fields from? All the way back to probably something that happened in the real world. Someone did a trade, someone went into a shop, someone clicked on a button on a website, but I want to know where my piece of data comes from, right? Now, this might all sound a little bit kind of abstract, a little bit ethereal kind of thing, but I've got practical problems that I've come up against in my career and things like that, so I kind of want to share those with you. And then we'll go on to a bit of a demo of a prototype that we've built, and then actually some opportunities that having that kind of lineage catalog actually presents to us. So the first example of a problem is ETL. So this is actually a kind of a cartoon of a system that I worked with, or that I worked on for a French bank about 4 years ago. Now they had 5 client sources because it's a bank, so why have one client source when you can have 5? And they needed a single version of the truth. They needed something that just said, hey, I've got this client, they did this trade, tell me about them. Now the problem with those 5 different sources is that they were all over the place. The rows overlapped with each other, they were inconsistent with each other, and you needed to combine them together in some magic way to actually aggregate them together and to then create some kind of clean data set on the back of it. Now this is to give you an idea of how costly and how expensive this was. One of those sources was this ginormous XML document, and it would take us about 12 hours to, and they couldn't supply us deltas either. They had to give us everything all in one go, and so our aggregation process took about sort of 12 hours or something. And then sort of on more than one occasion, someone said, there was a problem with that feed. Some of the clients from one particular area, we can identify those clients. They were wrong, they were bad. Great, I've got to run my 12-hour job again because I can't identify which of my aggregated records came from that source. So that's one problem. And I've got sort of another flavor of that problem as well. So if I go back to the start of my career, I worked at a software house and we used to create anti-money laundering and fraud prevention, fraud detection products for retail banks. So the way that we would do this, actually, if you've got a UK bank account, everybody is given what's known as a BOE code, a Bank of England code, which identifies the kind of individual that they are. Now, if your bank account is anything like mine, I get paid once in the month, and then it is downhill all the way. It is just debits the entire way. But if I'm doing something weird, what we would tend to see is that there would be a lot of deposits into a bank account from all manner of places, and then there'd be one withdrawal at the end of the month, which is completely different. So the way in which we used to do this, we would have different dimensions on the data, and we would kind of summarize that data, and we would compare someone like myself with my peer group, other people with the same Bank of England code or other aspects of the data. Now, the way in which this was happened, because this is going back about sort of 15 years or so, was the noble kind of SQL group by. Now this is so then we would kind of summarize in different kind of time periods, days, months, years, and also summarize the peers. So when you're outside of that normal distribution, then you're doing something unusual. Now the problem here is actually, this is a similar problem to the one I've just outlined, is that actually, if you have a problem in one of the transaction files, you've now got 6 batch jobs that you've got to rerun. And again, we had no way of identifying that, and we had no deltas. The daily summary, depending on the bank that was running it, that took about 8 hours, something like that. And if you've then got monthly summaries, that would run at month end, that was another 10-hour job, and so on and so forth. And so actually, we ended up having to cope with bad data and just live with it as a fact of life. But I don't think that's right. That shouldn't be a fact of life. We can do deltas, we can do this kind of calculation. Now, if anyone's ever worked on a risk system in a bank as well, this still happens today, this kind of problem, where people say, this file fell over, and these aggregations, my VAR aggregations, they haven't worked today. And so actually, then your bank is actually in danger because they have to report to the PRA in the UK. So what are my data lineage requirements, bearing in mind the kind of examples that I've just shown you? Lineage is non-static. So a lot of the tools out there, I'll come on to some of the tools in a bit. Lineage is non-static. So it can change over time where you get your data from based on code changes, based on new releases, etc. It can also change, within the one data source as well, because you could be getting your data from one place versus another. I wanted to be able to restate incremental changes, and because it's just embarrassing to say to a stakeholder, say, there was half a dozen records problematic. You can have that data in 2 days. That's just embarrassing. I want to be able to track those changes in data over time. I would love to do blue-green deployments as well. You know, we live in a world of continuous delivery. We do a lot of work at Open Credo on platform engineering and DevOps and things. And, you know, time out of number, I would hear, oh no, we can't do continuous delivery because we're a data-centric application. We can't do blue-green deployments because we've got so much data. We've got to wait for a database dump and we've got to we've got to run in parallel. And that can take, you know, best I can give you is 3 months, every 3 months. And I want to be able to track that poisonous data, that poison data, and where it goes. What's its effect in the rest of my data estate? And last one is cell-based security. I'll come on to that. I've got a kind of a worked example of that. So the design constraints that I wanted to add into any design that I wanted on this is that I didn't want the application to have to know, oh, there is this lineage thing that, and this is how I insert into it. I didn't want to have some kind of library in all of my applications or all of my, you know, say it's services, microservices, or different processes. I didn't want them to have to know about this. I wanted them to actually just be able to say, hey, look, here's my lineage. Do with it what you want. This is where this document came from. I don't care. I'm done with it. You catalog it. It's none of my business anymore. And so that actually pushes the knowledge of the provenance or the lineage down into the metadata. Now, there are some example or some existing tools out there, you know, some of which you recognize, some are commercial tools, some are open source tools. And a lot of them work by kind of keeping you in sync with your data structures. But that's not enough for me because they don't offer branching, version control, because, you know, if I've got a new version or a new expression of my lineage, I want to be able to say, well, this is a version that's coming soon. I want to be able to test with my catalog. And I can't do that if all I've got, all that, you know, I know that a few of those systems, you know, something like Apache Atlas, that only says this is how the lineage looks now. And it's sources A, B, and C, they go to source D, and that's that. But actually, I must give an honourable mention to Amundsen because they have it on their roadmap to be able to do branch-based, but they still can't do individual document-based lineage, which is what we'll come on to here. Now, I have a slight detour. Change data capture. Anyone using change data capture? Show of hands. Cool. Okay. So the database commit log, it's a sequenced, immutable log of changes that happen to the data. Does that remind you of anything? Begins with K, rhymes with Schmafka? No? Okay, maybe. So this is how, I'll come back to that. But so you've got a database. You've got different processes doing different stuff to the database. That's turned into a commit log. It's a sequenced log of the changes that are happening to the data. And when you do an incremental backup, or you do replication, it's the log that you're actually working with, rather than the actual kind of underlying data. Now, what products like Debezium do, change data capture tools, they will listen into that log and then they can do stuff with it. And what Debezium does, it hands it into Kafka, right? It's, again, our sequenced immutable log of changes. Now, if you ever heard Confluent say, we've turned the database inside out, this is why they say that. Because really, when you're running with a database, your commit log, that's kind of hidden away from you. You're just running SQL and doing updates and inserts and deletes and things. But actually under the hood, you've got this log. And what Kafka have done is that's the first-class citizen. That's what you work with. So we built a prototype. Now, there's a fair amount of moving parts in this, but I wanted it to be a little bit representative of the kind of problems that I've alluded to. So it was a simple kind of trade simulator. These are all Spring Boot apps. I generate some trades. I do some summarization on those things just based on the participant. What's the behavior that the participant's doing? Simple group by and count of the count of value and the volume of buys and sells. And then I kind of group that up again into a participant type summary as well. So that needs the peer group, its participants. So then I listen into that using Debezium. Debezium does its thing, shoves it down onto Kafka as change events. And then I've got a little CDCListener program that I've built, and that will write the lineage into two different databases. Now, Lineage is a graph. So I thought I'd put it into Neo4j, and then I thought for kind of just experimentation and just to see how that might work, because graph isn't everybody's cup of tea. I wanted to see how that would work with a relational database as well, and I will show you examples of the two. I've got a little bit of visible-ish. This is a Java class, so the Java layer will instantiate one of these and serialize it, turn it into a JSON document, and this is what gets sent with the SQL to the database. Now, and this is what the CDCListener, Debezium, can pick up and can work with. Now, even though my example is Java, it doesn't mean that Java has to be the layer, the application layer at all. As long as a JSON document like this is present in the insert SQL, then my CDCListener can pick it up and it can do something with it and actually can insert it into the catalog. So now I have a wee demo, or career suicide, as it was described to me. So I have running here. Is that in? Just. I did this every time, sorry. There we go. There we go, that's a bit better. So, and then I want the terminal up. So I have running here. So I've got Debezium server running. I've got Kafka plus Zookeeper, and I've got Neo running, and I've got Postgres running as well. So Postgres is actually fulfilling two roles here. It's actually part of the application landscape, but it's also got a Lineage catalog in it as well. So I will show you both of those. Now I have a little script here that I actually have on the screen at the top. So what this script does is it is posting to the Kafka REST endpoint to create new connector instances of the Debezium connector, so that that is a source connector in Kafka land. And that says to the Debezium connector, right, create me a new connection to this particular database, listen into this particular table, and send it down this particular topic. And there's 5 there or so. So that is that. And I have, so then I go to run. So actually, I should show you first. I can show you here. Not that I can see my mouse. There we are. Oh, come along. Hang on. I need to come out of presentation mode. There we go. And this is the Neo console. So I have some prepared scripts here earlier. So actually, I have nothing up my sleeve. So there's nothing there. So if you're not familiar with so Cypher is the Neo4j query language. So this bottom one here just says, get me all the nodes in the graph. And this top query here says, get me the entire graph. So get me the nodes plus all of the connections within it. So let's go back to our IntelliJ. So we need to run. Oh no, it's is this one. Right, so we need to run our CDCListener. This is really awkward to do this from such a massive telly remotely. So this is our CDCListener, so the service that picks up on those change events. Part of my Docker estate is actually is a flyway container, which ran some insert scripts to start with. So the reason that the listener, when it first picked up, you can actually see it's about to save, and it's saved. It's saved some initial input, which is some participants. So this isn't the actual data. This is actually metadata. That is not terribly clear. Yeah, so we can see there. So you can see down here is that actually I've got a participant here. It's a bit blurry on this one, but I'm hoping it's better on these. It's got a row ID of 2, and it's got its own ID field of 2, and that is actually a metadata descriptor. So look at this one here. Nope, not that one. And looking at the actual graph. So the graph, that is still empty because there are no connections between those things yet. So if I then run my order creation, so the order creation literally is just a little bit of code which will run, it just creates some orders and things. I can show you. Whoops. Oh, here we are. So this is just, let's get rid of that. This is just creating some dummy orders with some dummy participants in there, just so we've got a little bit of data in there to work with. So if I go to here, then we should be able to see, that's the whole graph. So that will still be empty, but this guy here, there we go. We've got some orders, and again, this is purely the metadata. I mean, I could show you. I've got a MySQL window or Postgres window open as well, but it's not terribly interesting. It's just rows of data. Like, let me show you here. So there you go. That's the actual data under there, and I do have the lineage recorded in here, which because that's now because it needs to be there in the SQL insert so that the listener can pick it up. It's actually persisted into the table, but now it's in the catalogue. You could even remove that if you wanted to. Yeah. So I've got my orders being run in there. Now I've got. Whoops. See, I broke my touch bar, so. I can't use any F keys, which is a little bit difficult if you're an IntelliJ user. So then I have so let's stop our order creation. I think that's quite enough of that. So then I can run my participant summary. So this is another Spring Boot app, but in the spirit of Spring Boot apps, it's not much in the way of Java. It's actually literally just running this piece of SQL. Now, the thing about this piece of SQL, so in the last couple of years, just when nobody was watching, actually SQL became a little bit cool again. So, so actually, it's got some really nice kind of aggregation functions. So I think the naming of this is Postgres specific, but a lot of the major database vendors have a similar kind of thing. Is that actually, I'm doing a group by here, but I'm actually aggregating the parents from the child records into a new JSON document, and actually that works within the confines of that group by. So what we should see is that actually within our graph now, so if you recall, there was nothing in the, oh, go away. So there was nothing in the, is that I can't see. Get the whole graph. Okay. So now where we had just a sea of nodes before, now we actually have lots and lots of orders in there. So what's that? That is a participant summary. And you can see that that participant summary hangs all of these orders here all contribute to that participant summary. Likewise here and here, okay? Now, if I choose, which way around do I do? Let me run the next step in the process. So the next step in the process is participant type summary. Oops. So if I run that, so this is another piece of chunk of SQL, which is very, very similar. So this is doing another group by as well. I could just show you that. So again, it's using our object JSON-B object aggregation here. It's doing like a switch statement as well to kind of just average out. Or rather, the previous piece of SQL did a switch statement, and this is just averaging out those kind of those sums and totals and things. So go back to our graph, and this might be a little bit it's a little bit awkward to see, but actually, if I do this. I'm looking for a participant type summary. I'm sure one here exists, but I'll grab a participant summary anyway. So now this is slightly tricky. There. So I'll grab that. I'll grab this. So this is, oops. Oh, marvelous. This is because I can't. Yeah, I can't see from this. This is slightly tricky at this angle. Did I get the string? Yeah. Cool, thank you. Look at that, mob programming. So here we have just one of those clusters, right? So you can see one of these clusters. That's not me. Thank you for saying that's pretty, but that's not my. It's not my work, unfortunately. Yeah, yeah. This is all out of the box functionality from Neo, but still, this shows you. This says for this participant record, what are all the records that actually gave rise to it? Okay. Now I can actually do this within SQL as well. So if I find here, so there we go. Then just run this. Now I've got, so this is kind of cool as well. So you remember I said that SQL became cool in the last few years when no one was looking. What this is a recursive query against a table. So the table actually contains a tree structure, and it's a self-join against that. So what you do is you give it a stopping case, which is my stopping case here, which is actually the lineage record I'm after, but keep joining back to that table until I find my entire record set. Now the problem with that is that you could get into a horrible infinite loop, recursive Stack Overflow kind of thing, but it's limited at like 10 or 20 iterations or something, which I think is a database level, setting. But what that shows you is that actually I've got, if I have a type summary or a summary record, and I want to find what are the records that gave rise to it, I can do that either within the graph database or I can do that within SQL as well. Now, if we look at our other, example, so say I've got one of these orders here, and that is actually poisoned. That needs to be rerun, and I need to find out where did that. where did that actually come from, or where did that actually go? Yeah, it was a nice presentation, but the guy sucks at copying and pasting. So something to actually mention here as well is that this is calling, this is not just vanilla Cypher. This is actually calling a library called APOC, which is awesome procedures on Cypher. And anecdotally as well is that if you remember back to the first Matrix movie, Cypher killed APOC as well. So that's where that comes from. It's all written by Neo4j, so I think they can be as flippant as they like. But what this says is, actually, I queried for an order, but actually, where did that order go? That order went to this participant summary, and it went to this participant summary. Oh, it looks like I've run it twice. Marvelous. And then it went to this participant type summary. And actually, I'm going to try and style it out that I've made a mistake within my live demo here. This shows, actually, that if you look at your data in different ways, you can actually start to see or tell patterns that should or shouldn't be there. So I should know that actually this shouldn't actually be participating in 2 participant summaries. It should only be 1. But actually being able to visualize my data in this way actually shows that actually there was something wrong with what actually happened. But the essence is still the same, is that actually if this order is poisoned, where did that go? Where did it go in the rest of my data estate? And that's what this shows you. Now you can also do this in SQL, again with our new friend. They have a fancy name which I can't remember, but the recursive call. And here you have it. And this one's a little bit easier to follow because there's fewer records. But here's my order, here's my participant summary, and another participant summary, and here's my participant type summary here. Now, interesting thing to note is actually the way the data is modeled in Neo versus how it's modeled in a SQL database. In order to get SQL to do the thing that I wanted, I had to store the relationships, the actual connections between the data. Whereas in a graph database, what's really quite neat is that you store the nodes and then you store pointers to them. So it's far more compact. So I guess what I'm saying here is your mileage may vary as to which flavor of database you want to use. Now, if I come back to my my presentation, so now that we've got this, and now that we're able to actually record the lineage for where does my data come from, where's my data going, it actually presents other use cases and other opportunities for use cases. So I mentioned cell-based security earlier. Now DBMSs are really good at saying role-based access security. They can do column-based security very, very easily. So actually, this query, this principal, they can only select columns A, B, and C. But they can't do row-level security because they've got no knowledge. You have to do that at the application level. And where you might want to do that, you might want to say, actually, I'm going to grant access to all the salary data, but people should only be able to see, or managers should only be able to see data from their team. Or maybe they need to see only data from Europe or data from the States, something like that. Now, Lineage, if you've got a lineage catalog, you're able to then trace where that sensitive data is going in the rest of your organization. So that you can actually then make judgments about the summarized data based on where it came from. Now, I've got a worked example of this. I don't have code examples for this because it's going to be really, really specific to the use case, but I kind of wanted to just sort of flesh out the idea behind it. So say I've got some kind of client process that creates a request. I look up that data in the source data, and then for every row in that, I want to recursively look up, is the principal, is my original client process, is that allowed to see this piece of data and all of the parents as well? And then afterwards, I can apply my column-based policies as well to redact anything. but that may have already been done at the DB level. So you can do 4 before 3. There's no dependency in ordering there. Now those rules can be as complex or as simple as you like. One thing that you could do as well instead, if you didn't want to kind of go through the whole the whole kind of looking up looking up the lineage on every row, because that can be expensive. If it sounds expensive, it probably is going to be expensive. So you could have a naming convention in the row IDs or document IDs to actually allow you to do that. That shows kind of where it's been, so it just concatenates that as you're going along. Now, the nice thing about Lineage is that it is immutable. Where a row came from, where a document came from, is going to be the same. It's never going to change, especially if you're using kind of append-only database structures as well, which I do highly recommend. It makes a lot of other things a lot simpler. But you could stick it in a cache, you could store it in a file, but something that is quick to look up on your application side. It allows you to then perform this kind of cell-based security. Now, I have a couple more examples as well. So ML, everyone wants to do ML. I think the maths is frightening, personally. But if you're going to have to explain your models and how your models work and what gave rise to a particular decision, or what gave rise to how we got to where we are, you've got Lineage, right? If anyone went to the it was the guy from Code in Blue, where they did the AI generation of unit tests. It was a very good presentation yesterday. They said they had something like, I think it was 1.2 billion parameters on some of the code, some of the input, some of the models that they were looking at. So, that's a fairly serious amount of data. But all of that data contributes to any decisions that are made on the back of that. If you're not generating JUnit classes and you're deciding whether someone is likely to have broken the law, perhaps, you really need to, it's really quite a serious problem. It's something that you really need to keep track of. So you want to be, MLOps is the new kid on the block, sort of DevOps for ML data, but you really want to maintain that integrity. And I'm not saying necessarily that you need to store 1.2 billion nodes in a Neo4j cluster, because you're going to need some help to do that, because that's pretty cutting edge Neo4j. But you might want to put it on some cold storage somewhere. But at least you've got to track that lineage. Yeah. So you might want to kind of have a manifest entry and so on in a table to define what that configuration looks like, and maybe that's a pointer to some cold storage, some S3 or something like this. But the point is that you need to be able to have all of those ingredients recorded somewhere so that you can come back to them if some regulatory authority comes knocking. Now, sort of a slight hobby horse of mine is sort of Bluegreen support. Now, when we started kind of working on this prototype, one of the main reasons for doing it was to look at Bluegreen support, because it was such a thorn in my side that I kept getting told, no, I'm a risk system, I can't possibly do a Bluegreen support, I can't possibly do continuous delivery. I said, well, question that. It really should be the way that you can actually deploy. Now, I think there is a way. Now, I thought that actually data lineage and recording data lineage would be the only way you could do it, but actually you don't necessarily need it. So if you have some producer process, produces data, and I've got a v1.4 and I've got a v2.0, they're both entering data into a database. Now, the way that we can do that, if we use semantic versioning, always use semantic versioning anyway, recording the major version, minor version, micro, and you've got some lineage in there, you've got some columns, who cares, right? Now, if you make your consumer processes aware of the possibility for other versions to be clouded in their source data, then they can just filter for it. No worries. And then they can understand what level of compatibility they are willing to support. They might say, actually, I can only work with the major version that I shipped with. Or it might be, actually, I can work with just even micro versions just for that particular use case. So coming on to some specifics for this. So you can do Bluegreen. You don't necessarily need that Lineage catalog. It does help, because if you know, if you know your data and where it's coming from, and your consumer processes are quite happy that they are partitioned off, your lineage data is going to help, because it gives you that final check and balance. Because if you're going to go blue-green all the way into production, for instance, and you go, actually, I'm going to choose the blue version, or I'm going to choose the green version, you really do want to be sure what set of data you're deleting from your production environment, and making sure that you're deleting the right set of records that you actually need if you're going to switch between them. So it just gives you that extra kind of safety blanket, which when you're dealing with prod data, and I kind of started this talk at the start, sort of not wanting to look embarrassed to a stakeholder, and if I said, oh yeah, it's great, I was able to rerun that thing, and it only took me 20 minutes, but I did delete the wrong set of data in production, and actually we're going to have a week's outage. I'm going to be looking for a new job. So so my key takeaways are knowing where your data comes from is important. Actually, on an initial draft of this, I actually had fake news on there. Wouldn't it be great if, when you get that comes up on your Facebook feed, that someone's trying to sell you a new tinfoil hat, and it says, well, the Bill Gates microchip that you have installed in you does this, so you need this new tinfoil hat. Knowing where that data, where that news story came from, that would be really helpful, right? And the current tooling doesn't cope well with history. What I look at when I look at those tools is, it's almost like a class versus object, right? The tools themselves say, well, that sources A, B, and C go to source D, but actually, for me, the different objects have different values. The different data points within that data set have different values. But then, actually, tracking lineage gives us some good stuff. I can then do my incremental and historic deltas. I can actually rerun things. I can actually pull stuff out of that data and rerun it, or drop it on the floor if it's poisoned. Allows me to track those tainted rows all the way from kind of farm to fork, if you like, from where it comes in all the way up to where it's served. Tracking models is going to be a thing. It's going to, that's not something that people are talking too much about. There's some work being done on explainability of models and how decisions were made, but actually, do we know for sure that actually we can go back to, if someone brings a court case against us in 3 years' time, can we go back to what was happening at that point and run that code up in a debugger, for instance? If you've recorded it, that's great. If you haven't, best of luck. Cell-based security, being able to trace where that data is. And as data becomes bigger and bigger and bigger, and becomes more and more connected and disparate from where it started life, do you know where your data's going? Can you keep track of it? Can you make sure that, can you say, hand on heart, this is where this data is and this is how it's secured, and it's secured throughout my estate? And also, if you take something like right to be forgotten as well, which is a big component of GDPR, if I said, well, actually, you're going to have to forget all of my transactions and all of my data that you hold about my transactions and all the summaries of that all the way through your estate, crikey, unless I'm able to rerun that or track it through the estate, then I'm potentially in breach in some way, depending on your use case. And finally, kind of blue-green as well. Everyone loves a bit of blue-green, and I think that's going to be really important, because as estates get bigger, applications get bigger, the amount of time, the amount of processing we want to do on data gets bigger. So we're not necessarily going to have the time or the patience to wait for a production backup of data to go into UAT so that we can work on that and then kind of test our new version and then go out and promote into production that way. We want to be able to run, the best sort of running is parallel running on real live data so that you can actually test kind of side by side with a live running system. So there's a link there to the Git repo. That's what the QR code is, because everyone else had QR codes, so I stuck it in while I was waiting at the back because it looked really handy. And that's all I have. Oh man, I have 5 minutes left for questions as well. So thank you very much.
Hi, thank you. At the start, you talked about a database commit log, how it's like a sequential, immutable sequence of transactions. And you asked, what does it remind you of? And the answer was Kafka. But it actually reminded me of blockchain. And I was wondering, does blockchain not also solve the whole problem of data lineage? And how does it compare to this?
So I did a bit of blockchain for a little while, actually. But it does in some ways. This will pollute the atmosphere a little bit less than a large blockchain cluster, a large Ethereum cluster or something. It does do that, but you don't have the same tooling over the top of it. You know, if you think about it, that blockchain is a really big linked list or Merkle tree. This will give you a more general purpose way of being able to kind of just work with it. And the tools for this are very, very familiar. You know, I run this within a SQL database, running that on top of an Ethereum cluster. I think it's RocksDB under the hood with Ethereum and things, which, you know, try getting that past a capital markets banking list. It's going to be difficult, right? So I think although the data structures are similar, and you can kind of trace some of that kind of lineage through it, it's just about making that data available. And for me, being able to work with that data is going to be really, really important because you know, I've got a stakeholder breathing down my neck that wants their report on their desk. You know, so well, actually, I've just got to write myself a smart contract. It's going to be a little bit more tricky, I think. But thank you, decent question. Good.
Hi, thanks for the talk. Well, one small thing before my question. I think your repo is private.
I can fix that.
Yeah. My question is this: the lineage. What's your rule of thumb? How much of it is metadata, and well, when should it be metadata, and when should it be built in the model?
Fair question. The first thing they teach you at consultant school on your first day on the job is the answer to any question like that is it depends. So I'm going to play that card, but I think you definitely need some document ID, some globally way of identifying your document, a globally unique way of identifying your document. I think if you're going to do something like Bluegreen, I think having the version information embedded in that lineage document, I think would be really handy because that's your use case. When you work with data, I'm sure you appreciate this, is that actually you've got to work or design your data based on your access paths. So what are you going to use that lineage catalog for? If you're going to do something related to versioning, then you'll want the version data in there. But you might want some extra metadata in there as well if you have something that keeps on cropping up, etc. So it's a bit difficult to say too much without a practical example, but there's no hard and fast rule with this. You know, give it a go and see how it goes. But I would say it's the minimum that you need in order to answer the use cases that you've got on the table. You know, how say for instance, if someone sort of says to you, well, you know, from this particular source, my data is always bad and you're always going to have to pull it up. You might want to say, actually, I'm going to denormalize that into the lineage record so that I can pick that out a lot easier rather than having to maybe join or look all the way back through the lineage to find where my ultimate source is. Does that make sense? Cool. Thank you. Cool. I think we're done. Thanks, everybody. Cheers.